Okay, so in this video, we're going to look at how we create our own Docker image from scratch by writing a Docker file. So what I'm going to do, I'm going to navigate to a directory that contains an analysis script in R plus some data. So it's the directory script data Docker demo. So I'm going to cd for change directory. Just going to do tab complete to complete the rest of that. I'm going to list the files that are in this directory. So we've got a folder called data, a folder called script, and a few other files, including a .rproj file. So if we look at the data file, we can see that we've got my_data.csv. We can use the cat, short for concatenate, just to display the output of that file. So we can see it contains two columns, variable 1, variable 2, and a bunch of numbers. So it's basically a standard CSV file. We can go into the script directory and look at what I've got. Plot my data.r script. So we can again display the contents of that. So we can see it's a very simple R script, loads a tidyverse, reads in the data, and then does a wee plot. Okay, let's go back up to the top level. So we're in our folder, so we're at the level where the .rproj file is, and the level at which the data and script directories are. What we need to do is create a Docker file. So we're going to create a Docker file using Notepad, Docker file. It says it doesn't exist, we want to create it, yes we do. And within the Docker file, we basically specify how we want our Docker image to be built. So we're going to build an image using the RStudio and Rockerverse versions 4.1.1. So the first couple of lines of our Docker file will say what we want to, what layers we want to use to build. So RStudio 4.1.1 and the Rockerverse. So that's the tidyverse set of packages for 4.1.1. To our Docker image, we want to add the data and script that we have locally. So we're going to say add in the data directory, my_data.csv. We're going to map that onto within our Docker container, a folder that we're calling data. Let's just keep it the same name, keep things simple. Also going to add from our script directory that's in our where we are locally, plot my data.r, and we're going to map that onto within our Docker container, the script folder. We're also going to add the rproj file. Might be useful to have that. Demo.rproj. Going to map that onto within our container, RStudio directory. So that's all we need to do to create this simple Docker file. So if we now simply save it and exit and click ls, we now see we've got a Docker file called dockerfile.txt. I have a funny feeling actually we don't need to have that text extension. So let's just rename it using the mv or move command. So let's just change it from dockerfile.txt to just dockerfile, okay? So now we see it's just called dockerfile. So that's everything in our Docker file that we've just written, which allows us to build our Docker image. So we can now do docker build. I'm going to call it my R image demo, and we're going to build it using everything we've got in our current directory. So if we press return, it'll start to build our image. It might need to, yeah, it's going to download a whole bunch of Docker layers. So what I will do is pause this video and let it do its thing, because otherwise you're going to be listening to me say nothing for 10 minutes or so. So I'm just going to pause this video now, and we'll come back to it once it's pulled all the layers that it needs from Docker Hub. Okay, so it took, maybe 10 minutes or so just to pull all those different Docker image layers from Docker Hub. I've noticed in PowerShell the fact that it tries to display blue text on a slightly different blue text background. Not overly helpful. You might want to sort of go into properties, potentially change colors, I guess, you know, to make that a little bit more, maybe make that a little bit more easier. Oh, and that's worse, gosh. I'll tell you what, I should have practiced this, shouldn't I? Colors, what did I do? Try that. Is that any better? Not really. At least we can read this bit now. Okay, you might want to play around with PowerShell to make it a little bit more, a little easier to read. So let's just type Docker images now, and that'll list all the Docker images that we've got on our machine. So you can see that our demo image that we created just a couple of minutes ago is now there. It's pretty large actually. So let's now fire that up and look at the Docker container that we've built using our Docker file. So Docker run. I'm going to set up the same ports. I think I've shut down all running Docker containers. We'll soon find out. Let's just connect to RStudio. And then password. And we're going to run my R demo image. Let's see how that goes. Yep, it's running. So let's open up our web browser to connect to it. Okay, type in the credentials. And we will see that we've got R version 4.1.1 with the script folder containing our plot my data file. Let's just open that. We've got our data folder containing the data, so we can run our script, loading the tidyverse, reading in the data, and then displaying a plot. So we're basically, we've run everything within our container. We've accessed our data file. We've run the script as well. So again, we're doing everything within our container. We haven't set things up so that we can connect locally. So let's go and do that now. Let's just shut things down. Is that quit? Just trying to shut down the container here. I think PowerShell might be hanging. Yeah, oh, there you go. Okay, so let's just make sure the container is shut down, so it's not shut down. So Docker stop container name will shut down the container. So we want to connect the Docker container that we're running based on our Docker image to a local directory on our computer. So let's let's go back to the UFO directory. So we're in our UFO directory. So let's now start up our container again, but let's connect the directory that we're in now, which is our local directory with the UFO stuff. So pass to our working directory and map that onto home RStudio, and we're going to create a new directory called local in our Docker container that's going to be our current working directory on our local machine. So we've got our container started, it's up and running. Let's connect to it. Log in again. I think I might have mistyped that. Nope, apparently not. So you can see now, as well as our script and data directories, we've also got our local directory containing all of our UFO stuff. And as previously, if you want to, you could write a new script here. You could write a new script in a local directory. You could, do statistical analysis. You could create an R Markdown document or whatever, which you could save locally. So it's a great way to be able to, run a particular version of R, a particular version of the R packages with, say some particular data sets or whatever, that then you can save the analysis locally, the script locally, or whatever. And again, this is a great tool for working collaboratively. It's used widely in industry. You could upload your Docker container that or your Docker image that you've just created to Docker Hub, for your colleagues then to sort of download themselves and work within the same container. So it's a great way to ensure you're all working with the same version of R, same version of the R packages. And not surprisingly, in data science jobs, very often organizations will have standard Python Docker images that you require everybody to use. So that's a reasonably detailed introduction to the wonderful world of Docker. You've seen how you can fire up a Docker container. You've seen how you can connect a Docker container to a local directory on your local computer. You've learned how to write Docker files to build your own Docker images, which allow you to fire up your own Docker container. You can share the image with others. You can access it in future if you need to go back and redo analyses at some later point in time. The lecture slides contain a few further examples, including how to write a Docker file for Python code. So you might want to have a go at doing that yourselves. It's the same sort of idea. You create a Docker file. In addition, for Python, you're also going to create an environment.yaml file, which contains information about the conda environment that you want to be running within your Docker container. So things like the version of Python, the versions of the Python libraries that you want to use, etc. But it's the same sort of idea. So I think Docker is absolutely a fantastic tool. It's just been an absolute eye-opener to me using it over the last couple of years. Containerization is an amazing way to package up your data, your analysis script, your computational environment, so that you can share it with others. There are alternatives to Docker out there, but Docker is really the tool that's become the go-to way of building these sorts of images. So I really encourage you to sort of, play around with Docker, create some Docker images, fire up some containers, see how you can modify them, perhaps try and share them with your colleagues. If you're interested in working in data science, you will be using tools like Docker every day, I suspect, alongside the core languages that you'll be using. In academia as well, Docker is becoming more commonly used amongst the more sort of computational savvy academics. It's an absolutely fantastic tool. So hopefully this has given you a good broad introduction to Docker, but actually gone into some depth as well, which will allow you to use it in a way that's going to really help you do open and fully reproducible research.